Hello everyone, in this video tutorial, we will see how we can do tennis shots identification and counting using YOLOv7 Pose Estimation. So this whole project can be divided into multiple steps and those steps are given below. So in the first step, we will download the YOLOv7 Pose Estimation weights. So we will be using YOLOv7 Pose Estimation weights for the key point predictions. In the next step, we will also download the sfpro.ttf font. We will need this font when we try to display the total shot type and the total shot count and the shot type in our UI. So we will be using a sfpro.ttf font when we display the shot type and total shot count in our user interface. Then I will create a virtual display in Google Colab. So why I need to create a virtual display in Google Colab? Because if I want to show the output video demo in the Google Colab, therefore I need to display a create a virtual display in Google Colab. Next, I will download a trained LSTM model from the drive. Basically, I have trained the LSTM model and I have saved the weights of the LSTM model into my drive. So I will download the H5 file of the LSTM model from the drive. So we have already trained the LSTM model on the backhand and forehand ground stroke data. In the fourth step, I will download some sample videos from the Google Drive for testing on the trained LSTM model for tennis shot identification. In the fifth step, I will download a tennis shot identification and counting script from the Google Drive. So while testing, we basically pass an input video to the tennis shot identification and counting script. So what does happen in the next step is that the input video is passed to the YOLOv7 pose estimation model and the key point predictions of the body are obtained. So just add here YOLOv7 pose estimation model and the key points of predictions of the body are obtained. And then the key point predictions are passed to the trained LSTM model for the shots prediction, like whether it is a forehand ground stroke or the backhand ground stroke. So I will also teach you how you can train your LSTM model on your own data. If you want to detect any other shot as well, so how you can train the LSTM model for that shot as well, or for any other data, for the cricket shot data. So I will tell you how you can train the LSTM model for any kind of data as per your requirements. So in the first step, we will download the tennis shot identification files from the Google Drive. So I have already downloaded this file. So just let me disconnect and delete this runtime and let's start from the scratch. So, okay. So just let me start it. Okay, I'm just correcting it. So before running the script, please make sure that you have selected the runtime as GPU and click on save. So hardware accelerator should be selected as GPU. Then click on save. And then you need to download the tennis shot identification files from the Google Drive. So it will be downloaded in the zip format, which you can see over here, but we will unzip it. So this file will contain the font file, sfpro.ttf font, plus it will also contain the plot file as well. So let me show you here. So you can see that we have the YOLOv7 pose estimation weights in that file, in that folder. We have the sfpro.ttf font over here. We have the plots file over here, which will help us to plot the skeleton plots on the body. Okay, so then we need to import the required library. So we need the NumPy library in this case when we try to convert our list into the NumPy array. So for that purpose, we are using the NumPy library. Then over here, we are creating a virtual display in the Google Colab so that we can show our output video demo into the Google Colab notebook. So just creating a virtual display into the Google Colab. So here I am updating the pillow library. Basically, pillow library is used when we try to create a rounded rectangle, like rounded bounding box. Because if you see that we have a square rectangle bounding box when the object is directed. But if we want to create a rounded rectangle bounding box when the object is detected, then we use the pillow library. So that's why I'm upgrading the pillow library over here. Then we are downloading the trained LSTM model file from the drive. So this model mmodel.final.h5. So basically the LSTM model is trained for the backhand ground stroke and for the forehand ground stroke. Okay. So here I'm just downloading some sample videos to test my trained LSTM model. So I'm just downloading the sample videos from a Google Drive. So basically, I have got the sample videos from YouTube and from the Pixel website. So I've just downloaded those videos from those sites and just placed these videos on the drive. So I can download this video from Drive directly into my Google Colab notebook. Okay. So now we download the coco.names files and the updated plots file. Okay, so now we will also download a tennis shot identification and counting script. So when we run this script, so it will do the tennis shot identification as well as the counting as well. Okay, so let me just run this script on a demo video, and we are selecting the device as Z0. We are basically using GPU, and this is the name of our video file on which we are testing running this script, tennis shot identification and counting. So I will also explain the script after this as well. So let me first run this script and see and show you the demo output, and then I will try to explain the whole process as well. Okay, so all the processing is done by frame, like you can see that all the processing is being done frame by frame, one by one. Okay, so it's 29 frames. Okay, let me show you one thing just over here. So you can see that after 30 frames, like it's 29 in the 30th frame, we got this sequence of, and this is the prediction of the current stroke. Like currently the player is playing the forehand ground stroke. Okay, so this is the predictions for the current stroke. What is the current stroke the player is playing, and this is a sequence of the body key points, like is the body is moving towards playing the backhand ground stroke or the forehand ground stroke. So this is the body key point estimation or predictions. You can see that, and this is the stroke the player is currently playing. Okay, so now after every 30 frames, we get this prediction. So if you can see here, after 59 frames, we get this prediction. On the 60th frame, the sequence or the key point predictions when the body is playing, when the player is playing the forehand ground stroke and the stroke name. So, okay, so this is the current stroke name, which is the forehand ground stroke. And in this list, all the stroke names of the previous and the current stroke is saved in this list, which we have created over here. Okay, so in this way, all the predictions are done after every 30 frames. Like you can see now it's 89 frame, and here we have the prediction that currently the player is playing the backhand ground stroke, and here is the body key point estimation or key point predictions of the body that the player is playing this backhand ground stroke, and you can see over here, and this short name is also saved in this list as well. Okay, which contains these two are the previous short names, and this is the current short name. The last name in the list is basically the current short name. Okay, and this is the key point estimation of the key point prediction of the body when the player is playing that specific shot. So it will be done after every 30 frames. So let's wait for this video to completely process, and then I will show you the output demo video as well. So guys, we have processed the complete video, and you can see here the predictions are done after every 30 frames. Okay, so here is the current stroke which the player is playing, like backhand ground stroke, and in this list we have all the previous strokes. In this list, all the previous strokes are saved over here, which you can see. So I have displayed this demo output video into our Google Colab notebook as well. So this is the output demo video into our Google Colab notebook. Let me download this video and show you how it works. Okay, so just let's play this output demo video and see how our results look like. Okay, so just let me navigate my screen towards this output demo video. Okay, so I think now you can see that. So this is the output demo video. So let me tell you one thing. We are only detecting the shot type for this player 1. Okay, we are only detecting the shot type for this player 1. We are not detecting the shot type for this player. Okay, so for this player, we are not detecting the shot type. We are only detecting the shot type for this player 1, which has the bounding box and the label as person. So we are here detecting the shot type as forehand ground stroke, and the total shot count here is appearing as well. So let me play this output video. So you can see that currently the player has played the backhand ground stroke, like you can see over here. Like please, I am only detecting the shot type and the total shot count for this player only. Okay. So now you can see that currently the player is playing the backhand ground stroke. So you can see over here, it's appearing backhand ground stroke. And also you can also see that here we get an increment as well from 2 to 3 that the player is playing the backhand ground stroke. Okay. So why we are not detecting for this player, like you can say why we are not detecting the shot type and the total shot count for this player, like the player 2, because if you see over here, this player, in some cases we are not getting the poses for this player, like the pose estimation or the key points of the body for this player, while this player is close to the camera and we are getting the correct key points of the body, you can see over here, while we are not getting this player key points in each frame. Like you can see that in this front frame we are missing the key points of the body of this player because it is far away from camera. So instead of our model giving wrong predictions for this player, we are only focusing the shot type and the total shot count for this player. Only for this player, we are only interested in detecting that shot type and the total shot count for this player only. For this player. Okay. So we are only detecting the shot type and the total shot count for this player, and we are not interested for this player. Okay, so you can see that the player is playing the forehand ground stroke. So our model is detecting correctly that the player is playing the forehand ground stroke. You can see over here, the player is playing the forehand ground stroke, and now his pose is towards the backhand ground stroke. Like so, here you can see that the model has detected that the player is playing the backhand ground stroke. Okay, so this is how our output video looks like. Let me go back to the code and then we can discuss further over here. So let's see. So here you can see that we have trained the LSTM model to detect the shot like with the whether the player is playing the backhand ground stroke or the player is playing the forehand ground stroke. So we have trained the LSTM model for this purpose. So let's look at the complete process how to train our LSTM model. So this is the complete process on how to train our LSTM model. In the first step, the dataset of different tennis videos was gathered from YouTube. So let me show you. I have downloaded the tennis videos data from YouTube and save into my local directory. So let me just show you. Okay, so if I go to here and just give me a minute, I'm just navigating the screen towards the files where I have. So let me just navigate my screen. So if you see this dataset folder on your screen, so you can see that I have downloaded different tennis videos from YouTube. So these are the different tennis videos which I have downloaded from YouTube. I will share this dataset as well with you. Okay. So then I have, let me show you. Then if you see that I have separated these videos, like I have trimmed these videos for the backhand ground stroke and for the forehand ground stroke. So like you can see that I have already trimmed these videos for the backhand ground stroke. You can see over here. Then I have also trimmed these videos for the forehand ground stroke, which you can see over here. Okay. So I have trimmed these videos when the player is playing the backhand ground stroke and when the player is playing the forehand ground stroke, and I have saved those videos into the separate folder. Okay. So let's go back to the code. So in the first step, the dataset of different tennis videos was gathered from YouTube. So I have shown you that I have gathered different tennis videos dataset from YouTube. In the second step, the time span when the player is playing the backhand ground stroke or the forehand ground stroke are trimmed and saved into the separate folder. So I have shown you as well that I have saved the backhand ground stroke videos and the forehand ground stroke videos in the separate folder. In the third step, each video frame was fed into the YOLOv7 pose estimation model and predicted key point landmarks, X coordinate, Y coordinate, and the confidence were expected and stacked together as a sequence of 30 frames. Okay, so let me show you this third step. So here I am just downloading the key points finder.py script. So this find the key points of the body when the player is playing a specific shot. Okay, so here I've just passed a video 1.mp4. So this is the video of the player when the player is playing the, you can say backhand ground stroke. Okay, so this is the video. In the video 1, we only have the video in which the player is playing the backhand ground stroke. So in video 1, the player is only playing the backhand ground strokes. Basically, the video one is the trimmed video from the original video in which the player plays the backhand ground stroke. Okay, so when we run the key point finder script like here, so you can see that we got these key points of the body after every 30 frames. Like you can see that we got the key points of the body after every 30 frames when the player is playing the backhand ground stroke. Okay, so in this list, this is the key points of the body for the first 30 frames, and in this list, like you can see here, like this is the key points of the body after 60 frames when the player is playing the backhand ground stroke. And in this, the below list, we have all the key points saved from first 1 to 30 frames and the 30 to 60 frames. So in this list, we have all the key points saved from 1 to 30 and 30 to 60 frames. Okay. So basically, after we get the key points from here, we just like you can see that this is the key points of the body from. Okay, so this is the key points of the body which we got from the whole video. Okay, this is a very long list, so we just save this list into the like you can say in the form of numpy array. So you can see the shape of the numpy array. So in this current video one, we have 10 different sequences which has a length of 30 frames. Okay, which basically which has a which are appended with 30 frames. Okay, so and the length of the the sequences which contain 30 frames, the length is 10, and 51 represents the key points of the body. Like 17 key points are for x coordinate, 17 key points are for the y coordinate, and 17 are the confidence values. Okay, so if I show you the output demo video over here, just setting my, okay, so you can see that this contains only the key body when the player is only playing the backhand ground stroke. Okay, so in this case, the player is only playing the backhand ground stroke. You can see over here. Okay, so we have only found out the key points of the body when the player is playing the backhand ground stroke, and we have saved those key points in the form of the array. Okay, so and the shape of the array you can see over here. Okay, so in this way we are running multiple videos and finding the key points of the body when the player is playing the backhand ground stroke. You can see that we are not doing for video 2, and now we are doing for video 3, we are doing for video 4. So we are basically collecting data of the key points of the body when the player is playing the backhand ground stroke. Okay, so we have collected the data from 70 videos and 7 videos when the player is playing the backhand ground stroke, and we are saving this data in the form of an array. Okay, now we are collecting the data when the player is playing the forehand ground stroke. So now we are just passing different videos when the player is playing the forehand ground stroke, and we are collecting the data and converting it in the form of numpy array. Okay, so these are very much, so if you see it, you will get the understanding as well how we are basically doing it. So let me show you finally what data we have. So just give me a minute. Okay, so here we have the so final backhand ground stroke data contains the data which we have collected when the player is playing the backhand ground stroke, and final forehand ground stroke is the data which we have collected when the player is playing the forehand ground stroke, and the total data shape is 203, 30 and 51. Okay, so now we are importing the required libraries to train the LSTM model. So here we have imported all the required libraries which are we use to train the LSTM model. Okay, so here you can see over here, we are doing the train and test split. We are using 80% of the data for the training and 20% of the data for the testing purpose. And here we are just training our, so here is our LSTM model. We have 4 layers of LSTM and 3 layers of dense layers, and we are using sequential method to implement the LSTM model. And here we are training our LSTM model, which you can see over here. I have already trained the model for 500 epochs, you can see over here, and we are getting categorical accuracy of 98.77 for the training, and the validation accuracy 73.17%, which is very good. Okay, so after training the model, I am just saving the model in this h5 format, .h5 format. So in the above script, I have told you that I am downloading the model from the Google Drive. So after saving this model, in the .h5 format. I download this model over here and place this model into my Google Drive. So when I need to download this model into the Google Colab notebook, I directly download the model from the Google Drive into my Google Colab notebook. Okay. So this is the whole process. Let me try to explain you the tennis shot identification and prediction script. So if you know the tennis shot identification and prediction script, then key points finder script will be a no worry for you. Okay, so here we have the tennis shot identification and counts.py on which we run our demo video. So let me try to explain you this script. Okay, just set this as well. So let me just open the script over here, which is this. I have already added the comments. So if you just check the comments, so it will be very easy for you to understand. So I'm just opening the script over here and I will explain you the complete script as well. So just give me a minute. Okay. So I'm just expanding it a bit on the left side. So in the first step, we are importing all the required libraries, which you can see over here. So here I'm importing all the required libraries. Then I am creating a empty dictionary by the name object counter. So here I've written creating an empty dictionary to save the total shot count of each shot type. So just writing it to save the total shot count of each type of stroke. The first element in that dictionary is the key, which contains the shot type. For example, if the player is playing the backhand ground stroke or the forehand ground stroke. The second element in the dictionary is the value, which contains the shot count of each type of the stroke. For example, in the value section, we have the shot count for each of the stroke. For example, forehand ground stroke is played by the player 10 times, while the backhand ground stroke is played by the player 4 times. So in this dictionary will contain the total shot count and the shot name as well. Okay. Then I am just creating a function by the name load dash classes. You can see here, using this function, we will load the coco.names file and read each of the object name. So in the coco.names file, and this function load dash classes basically return all the object names in the coco.names file in the form of list. So all the object names like we have in the coco.names file will be returned by this function in the form of a list. Okay. So now this is our main function run. So here we are just passing the YOLOv7 pose estimation weights. By default, we are setting the device type as CPU, but we are using GPU when we do the predictions. And here is our coco.names file over here. And here I am defining the thickness, like the thickness of the skeleton points of the body. Let me show you what I mean by the thickness. Okay, so okay, let me explain this to you. Okay. So by thickness, I mean this. Okay, so I mean this thickness of these key points of, okay. So these line, I mean the thickness of these lines. So I'm currently set is 2, but if you increase this to 4 or 5, these lines will become further thick. Okay. I'm talking about these lines, which are yellow, blue. Okay. So let's go back to the code again. So, okay, so here we are just setting the classes, camera capture and passing the video path and defining the height and width of the output video. And here I'm just loading the sfpro.ttf font, which we have downloaded. So let me show you where we are using the sfpro.ttf font. So here you can see that this text is written in the sfpro.ttf font. This text is written in the sfpro.ttf font. This text is written in the sfpro.ttf font. This text is also written in the sfpro.ttf font. This text is also written in the sfpro.ttf font. Okay. So let's go back towards the code again. Okay. So here we are just loading our trained short identification model. So here we are just loading our trained short identification model. We have saved the H5 model in the form of .h5 format. So here we are just loading the trained short identification model over here, which we have trained with LSTM. This is the basically trained LSTM model, okay, which I have explained you below. So this is a trained LSTM model file. Okay, so here we are just creating the empty list, and here we are defining the strokes. So we have two types of strokes which we are detecting. We are detecting backhand ground stroke and the forehand ground stroke as well. Okay. So in the first step, we will do for the player 2. So in the first step, we will find the key points of the body for the player 2. So let me show you. Let me share my screen. So just give me a minute. So So if you see my screen, this is our player one, this is our player one, and this is our player two. Okay, I've written as well. This is our player two, and this is our player number one. Okay. Okay, let me just go over here. So first we will find the key points of the body for player 2. So here we are just creating a black mask, and then we are defining the ROI for the player 2. So ROI means region of interest for the player 2. So what does it means? So it means basically we are defining this key coordinates. So okay, so in this, to find the ROI for the player 2, we create a straight rectangle and to further use these coordinates, which are x1, y1 and x2, y2. Okay, so how we get this point? Please focus over here. When I try to explain, please focus on this. So if I go over here, now you can see that the current coordinates are of x1 and y1 are 141 and 164. So if you focus over here, if I go towards this, so current coordinates of x2 and y2 are 1055 and 356. Okay, so if I go towards the code, so here I've just passed the x1, y1 coordinates, and here I've just passed the x2, y2 coordinates for the player 2. Okay. Okay, so sorry, I am just talking about this player. This is the player 1. So currently we are using first the coordinates for the player 2. Okay, so these are the x1, y1 coordinates for the player 2, and these are the x2 and y2 coordinates for the player 2. So if you go over here, we see this point. So currently these are the 73, C71, and it is currently 12,657. Okay, so let me go back towards the code again. So currently we are finding, we will find for the player number 2. Okay, so we are finding a region of interest for the player 2, and then we will calculate the skeleton points for the player 2. So now here we are finding the key points or the skeleton points for the player number 1. As I've shown you, the player number 1 is above the bluff player. Okay, so here we are just creating an black mask over here, and here we are just finding the region of interest for the player 1. We are past the x1, y1 coordinates, and here we are past the x2, y2 coordinates. Okay, over here. Okay, so in the next step, you can see over here, if we go below, so here we are just plotting the skeleton points for the player 1 over here. And if I go below, so if I go below, I will be plotting the skeleton points for the player 2 as well. Okay, so here I'm just plotting the skeleton points. If I go below over here, so here I'm just plotting the skeleton points for the player 2 over here. Okay, so okay, over here you can see that. So here what we are doing is that if the length, so as we are only detecting a short type and the total short count for the only the player number for only this player. Okay, so as we are detecting only the short type and the short count for only this player number 2. Okay, so what we are doing is that, okay, let me go back to the code. Okay, so as we are detecting only the short type and short count for the player 2, so as we process the video frame by frames, okay, so what we say over here is that, okay, let me go further. So when the sequence length is equal to 30, like we made prediction after every 30 sequences or after every 30 frames. Okay, basically we do the prediction of the stroke the player is playing after every 30 frames. So if the length of the sequence, like if the 30 frame have passed, if the 30 frames have passed, then we do the prediction like what the currently the shot of the player is playing. So tf.model.predict will do the prediction what currently the shot is playing after every 30 frames, like you can see over here. And then using in the pose name, we have to find the poses, backhand ground stroke and the forehand ground stroke. So here we got the stroke name or the pose name from here. Okay, so then we will save all the sequences in the form of in the key points list over here. Okay, and we will save the poses names as well. So now here we have created object counter. So we are saying that if the short name is not in the object counter dictionary, then add the name. Okay, so if the short name is not in the object counter dictionary, then add the name. If the short name is already there in the object counter, then just increment the counter. So we are just incrementing the counter over here. Okay. So when the value of j becomes equal to the value of sequence, which is 30, and when the value of j becomes equal to the value of sequence, which we have defined as 30, then remove all the previous values of sequence and set it as empty list and start processing the next frame. So we have when the value of sequence, we have defined the value of sequence over here as 30. Let me show you. So we have defined the value of sequence as 30 over here. Okay, so when j is the value, so basically j counts the frames. Okay, in the j value, we have the number of frames value stored. So sequence, we have defined 30, like after every 30 frames, we will do the prediction. Okay, so in j we store the value like how many frames have passed. Okay, so when the j value becomes equal to the sequence value, which is 30, like when the j is 30, it means the 30 frames have passed. So, okay, then we will make the prediction, and also we make the sequence list empty, and j is equal to 1, like will start from 1 again. Okay, so like I have shown you that after every 30 frames have passed, let me show you. Okay, let me show you. Like after every 30 frames are passed, we usually make the predictions like what the current stroke the player is playing. Like if it's playing the forehand ground stroke or the backhand ground stroke. Okay, so here we are displaying the backhand ground stroke over here, and so if the player is currently playing the backhand ground stroke, we are just setting these values like where we want to display it in the UI. And if the player is playing the forehand ground stroke, we are just adjusting the UI where we want to adjust set these values or the line in the UI, and we will want to put the text like currently the player is playing the forehand ground stroke. Okay, and here we are just defining the total shot count, like where we want to display in the UI, like where the total shot count in the UI appears. So let me show you. So basically in all this below, we are just setting this like in where in the UI I want to display this total shot count, and where in the UI I want to display this total shot count, and where in the UI I want to display this shot type. Okay, so we are just adjusting this shot type and the total shot count in the UI using this. Okay, and this is all from the code, and see you all in the next video tutorial. Till then, bye bye.